Humans see words with meaning. I see them as sequences of characters, just letters and numbers. But to truly understand language, I use something called lemmatization. It helps me find the base form of words. I use dictionaries and linguistic rules to connect words correctly. When you search for best ways of running faster, I also look for good ways to run fast. Makes my search results more accurate and helpful. I understand what you mean, not just what you type. My goal? To think a little more like humans. To bridge the gap between what I know and what you feel, making language not just functional, but meaningful. Without lemmatization, these different ways of asking could cause confusion or lead to irrelevant answers. But with it, I get to the core meaning.
Hello, Mr. STEM. We often get compared, but I believe we serve different purposes.
Absolutely. People think we do the same thing, but we take different approaches to simplifying words.
I focus on finding the dictionary form of a word while keeping its meaning. For example, I change better to good because I understand that they are related.
That's impressive, but I take a much simpler route. I just remove common suffixes and prefixes. For example, running becomes run. I don't care about meaning, just shortening the word.
That's where we differ. I prioritize accuracy, while you prioritize speed. You work well when people need quick processing, like in search engines.
And you work well when understanding is needed, like in chatbots and AI models. But let's be honest, what happens when you can't find the perfect lemma?
Good question. Even if I struggle, my approach still tries to maintain meaning. If lemmatization fails, the solution isn't to use stemming instead. It's to improve the lemmatization algorithm.
So you're saying that even if you're not perfect, I can't replace you? Exactly. Stemming is useful when we just need to reduce words quickly. But when meaning matters, it's not an alternative to lemmatization. That makes sense.
Hello, Emma. I heard you're curious about lemmatization. Did you know there are different types of it?
Wait, I thought lemmatization just means finding the base form of a word. What different types are there?
Good question. Depending on how deep we go into meaning and context, lemmatization can be categorized into three main types. First, dictionary-based lemmatization. Second, rule-based lemmatization. Third, machine learning-based lemmatization. Dictionary-based lemmatization, e.g., running to run. It's simple and efficient but struggles with rare words or new vocabulary that not the dictionary. It's best when accuracy is not the top priority. Rule-based lemmatization. For example, if a word ends in ing, it might be converted to its base verb form. Running, run. Swimming, swim. However, this method isn't perfect. It struggles with exceptions. For instance, lying should become lie, but a simple rule might incorrectly change it to ly. Rule-based lemmatization is more flexible than dictionaries but still has some limitations with irregular words. Machine learning-based lemmatization uses AI models instead of fixed rules or dictionaries. Considers context to determine the correct lemma, e.g., seen, see, but sawed remains saw. Adapts to complex language structures for better accuracy. Requires large datasets, training, and computational power. Used in advanced NLP libraries like Spacey, Stanford NLP, and transformer models. So, in summary, dictionary-based, fast, but limited to known words. Rule-based, more flexible, but struggles with exceptions. Machine learning-based, smartest, but computationally expensive. Each has its place signification. Choose wisely.
Challenges in lemmatization. First, context dependency: barking, dog sound or tree bark. Meaning changes with context. Second, handling irregular words: went, go, better, good, rules don't always apply. Third, computational complexity needs linguistic databases, unlike quick and dirty stemming. For multi-language challenge, English rules don't work for French or Hindi. 5, ambiguity in morphology left, past tense of leave or a direction. 6, real-world impact chatbots, search engines, and AI assistants suffer from mistakes. Applications of lemmatization. First, sentiment analysis. Converts loving, love for better sentiment detection. Unifies word variations, love, loved, loving, to improve accuracy. Moving on to next application, chatbots and virtual assistants. Simplifies words, booking, book, for better intent recognition. Helps chatbots understand user queries more accurately. Lemmatization equals smarter AI. The future of lemmatization. First, AI advancements in lemmatization. Smarter AI models. Second, context-aware lemmatization. AI will understand meaning beyond just rules. Third, real-time lemmatization for AI assistants. Chatbots and virtual assistants will process speech instantly. Fourth, multilingual and cross-language lemmatization. Lastly, AI-powered sentiment and intent analysis.